Hello, everybody. My name is Michael, and we're going to get started here because we're a couple of minutes late. So apologies about the technical disruption, but let's move right ahead. Shout out to all the sponsors of this event. It's always fantastic to see organizations sponsoring these types of free community events. So we are very grateful for everybody who is involved, including, of course, the organizers, but especially the sponsors. So just a little bit of quick, brief background about myself. My name is Michael. I am a consultant based out of the San Francisco Bay Area, and I've been working with Microsoft Technologies for at least a quarter century now. And I work for a company called CCO, so I'm a partner there. And what we do is we do a lot of work setting up Microsoft infrastructure for various clients. So that's traditionally been things like SharePoint, Exchange, Active Directory, but more recently that's included a lot of Azure type of cloud utilities. We do a lot of work within the security space, which is where I've been doing extensive work over the past about 2 years or so. And so that's really kind of where this session came from. I do get out and travel a lot. That's one of my passions. I enjoy getting out and evangelizing, spreading knowledge. And if you actually look in the background there, that map is a Power BI map that shows all the different locations around the world that I've spoken in. If there's a bigger circle, it's multiple speaking opportunities, things like that. So obviously this year has been a little bit of a different year. I've been doing online events. I think this is around the 8th or 9th online event that I've done, and I'm doing a few more later on this year. So, of course, 2020 is different for everybody. I do hope to get back to traveling at some point when it's safe in the future. So hopefully I'll be able to see you either in Germany, France, or wherever you're coming from. So let's go ahead and get started here with a discussion of really what has changed within the IT security landscape. There's a few things that are really different now in IT security that weren't the case even as recently as just a few years ago. For example, one of the things that we see a lot of now is something called spear phishing attacks. And what those are targeted attacks that go after individuals within your organization. And generally speaking, they're going after either management, someone higher up within the organization, or they specifically target people within the finance department of your organization. So not necessarily even like a high-level person, but somebody who they think might be able to handle, payroll or checks or bank transfers and that type of thing. So we see these spear phishing attacks go after individuals, and the hackers actually are fairly sophisticated in how they do this. One of the common techniques is they'll actually go research a company. They'll research people that work there by looking at things like their LinkedIn profiles, and then they'll kind of find who within that organization is within those various departments or who has a high-level title, and they'll essentially guess the email address based on what your email address formatting is publicly known as, and that's actually fairly easy to figure out. And then the next thing you know, they've sent an email off to that executive or that finance person, and that email will include some form of a payload to try to gain control over their system. Oftentimes that payload, it may be something like an infected macro in an Excel spreadsheet. We've seen that a lot recently, but it also may just be directing them to a website, a nefarious website to do credential harvesting. So that's where they'll go ahead and ask them, do a prompt for their username and password. And users, unfortunately, are fairly blind to the risk around just throwing in their passwords. They do this a little bit too often for their own benefit, and so what ends up happening is that they share their actual real credentials, their corporate credentials, with this nefarious website. And of course, the first thing that website then tries to do is tries to log in as their email, try to get into the platform, and once they're in, there's any number of things that they can do. Of course, they can try to initiate bank transfers. They can try to, switch someone's payroll over to going to a different location. Most of the time, these types of attacks are motivated by financial gains, but in some other cases, there are other reasons why they may want to go in there and target an individual. And what we're also seeing is that the amount of money that's being thrown at these types of hacks has gone up exponentially. And a lot of that's due to the fact that, 10 years ago, if someone was doing some form of hacking, they either got paid very little or they weren't really in it for the money. They were just doing it to see if they could do it, or for the lulz, or whatever you'd call it. Nowadays, though, that's changing. We're starting to see a lot more state-sponsored attacks. So individual states will set up these large server farms and large cubicle farms where there are people constantly dedicated to attempting to hack not just the governmental institutions of a different state, but also some of the enterprises. And in some cases, they may be doing that for financial reasons. They're trying to essentially gather up money to support their efforts. But in a lot of other cases, there are political reasons behind that. So they'll try to hack to embarrass a particular politician, or maybe they're, in some cases, they may be mad at a film company for creating a film that was not necessarily well received by their government. And so that's actually a real case. That's what happened with Sony Pictures. But we've seen many other types of attacks that aren't necessarily as well publicized as that particular one. We're seeing a lot of instances where intellectual property is either stolen or is accidentally lost. And when I say accidentally, it's actually well too common and too easy to do what we call oversharing of information. And that's where someone may have some kind of confidential spreadsheet or a Word document, and they post it to some online cloud service, and they mean to share it with only a specific partner or somebody else. And what they end up doing is they share it to a much larger audience. Oftentimes we'll see that where people are just sharing via links instead of sharing via individual accounts, because if that link gets out there to anyone else, then all of a sudden people can get in and gain access to data that they wouldn't ordinarily be able to have. So those types of things really complicate the landscape with those kind of targeted attacks. Other types of challenges within this changed landscape include data integrity challenges. So we see issues with ransomware. That's actually become very, very common nowadays, where someone will gain access into a system, and potentially they gain access into that system through the front doors that I talked about, so through some targeted spear phishing attacks. And once they gain access to a system, they check to see, they do what's called a lateral attack to see what type of capabilities they have on other systems. So they may do an attack to see, okay, which servers do I have read-write access to? Where can I make changes to? Once they know that, then they're able to go through and encrypt everything in the locations where they have write access to, and then essentially hold the key hostage. The idea being is that you don't get the key back unless you actually pay a cryptocurrency type of sum in Monero or Bitcoin or some other cryptocurrencies. So we see those types of hacking attacks happen all the time, especially since people's domain security may not always be set up the best way. And there are, for example, too many domain admins. And as you may realize, of course, if someone gets in as a domain admin, they now pretty much have unfettered rights to every system within that domain, which means that they can go out to every workstation, every member, every server, domain member, and encrypt everything on those, and literally leave those systems in a state where they can only be decrypted with the ransomware key. Other issues around data integrity in the cloud. As convenient as the cloud is, we're actually starting to see specific attacks and then hostage type attempts with your data that actually go through with threats of what we'd call permanent deletion of that cloud data. And cloud is great, but there are some downsides to the cloud. One being is that, for example, in Office 365, there's really no native backup mechanism. There's a way to recover files within a particular period of time, but admins on the back end can actually bypass that type of recovery and can do what's called a permanent deletion of data. So if you're an admin in Exchange Online, for example, you can run a single line of PowerShell to completely not just delete a mailbox, but delete the back or essentially the saved retention copy of that mailbox. So that kind of thing is sometimes, again, it's essentially an evolution of where ransomware started. As now we're seeing that start to move into to cloud-based tools as well. The device security has become an issue. Of course, we've traditionally dealt with theft and compromise for quite some time. People lose laptops. You want to make sure that the data on there is encrypted. But at the same time, I mentioned payloads from these hackers. Sometimes they include specific keyboard loggers, rootkits. Once they're in on a system, particularly if that user that ran that bad Excel macro or that other that executable that's or that's disguised as a PDF, when they are local admins on those boxes, they can then essentially take over everything. They can take over the camera. They can log all the keystrokes, and many times these hacks start like that. The hackers can actually be in the systems for weeks gathering information, gathering intel, and looking for a more strategic target. In fact, that's exactly what happened in the Sony Pictures case, is they were in the system for weeks before they finally unleashed their payloads. So, that kind of thing creates its own security implications. At the same time, IT is overloaded with information. We may be getting alerts from the firewall, from the syslog, but there's just so much noise in that alerts that it makes it really difficult to understand, to be able to separate the noise from the signal ratio within IT and to stay that one step ahead of the attackers. So while all of this is going on, the best practices around passwords has been radically changing. If you think of best practices around passwords back in the day, I think back to I was actually recently watching the old movie from the 1980s, War Games, and in War Games, the guy basically gets in by guessing a password. The password was the creator of the operating system's son. It was a very simple password, but that guy at the time thought, well, okay, there's a whole bunch of passwords that are out there. I'm just going to use this very specific one, and it's going to be good enough for the 1980s. Well, it wasn't even good enough for the 1980s. It almost caused a global thermonuclear war. That's besides the point. But the point is that passwords evolved. Eventually, people started to realize, well, let's put some more complexity in it, uppercase, lowercase. Well, the problem is now is that your password, it's not just about the complexity of it or even how long your password is. The real key is how unique is your password. If your password shows up anywhere else and is used in any other system, it's no longer a very secure password. And the reasons for that is that that other system that you may have entered that password into may have been compromised at some point. There is a database out there of over 744 million passwords that have been hacked and are included in what you would call dark web databases. You can actually go to, there's a website that's kind of a white hat hacker website. It's haveabeenpwned.com, and that's actually that ties into that data, and it can be used to test those. Actually, you can download. There's some Microsoft toolkits to download those password databases as well too, to test them against your own Active Directory databases or Active Directory passwords. In any case, so what ends up happening? Let me give you another scenario that is unfortunately very, very common. You have people log in with their corporate passwords, and hopefully you've told them, hey, don't use your Facebook password, don't use a home password, use a corporate password, and usually they do. But then at some point they sign up for some other web-based service that is part of their job. Now that web-based service, if it's not hooked in directly in via Azure AD or SSO or some other SSO solution, they have to enter in a new unique password that's only used on that site. Of course, out of convenience, most people choose the same password as their corporate password because it's for work-related purposes, and who wants to remember all those passwords anyway? Well, next thing you know, that that particular website, they may not have had the best password protection in place. They may have been hacked at some point. Those passwords get compromised. They show up in the dark web databases. The first thing that hackers do is they attempt to log in as that user with that particular password, particularly if it's a relatively fresh password. And if you don't have multi-factor authentication in place, all of a sudden they've now authenticated as your corporate users. That happens a lot. And this is one of the reasons why, no matter what, at the end of the day, the number one thing, the best thing that you can do to secure your environment is to set up multi-factor authentication, to set up MFA for your users. That way, the attackers, even if they have the username and password, they'll also need that additional factor. They'll need, the Microsoft Authenticator, Google Authenticator app password from your phone, or they'll need an SMS text message, which is not as secure, but is still better than just a username and password itself. The other things I try to get people in the concept of doing is to use something called a passphrase instead of a password. And what a passphrase is that it's a series of words. So I gave an example here, 4 words: yellow, birdseed, hat, pumpkin. The reason why a passphrase is better than a password is that passphrases are very easy for humans to understand. It's very easy to create a little mnemonic in your head to remember a series of words. However, for a computer, it's much more difficult because it's such a long password that when they're running brute force attacks, it's of course extremely difficult to brute force a password that's as long as that. Now, of course, if that passphrase is not unique, and if it's in a dark web database, then they'll be able to crack it within seconds. Because I will say, 744 million passwords. Using the tools that I mentioned earlier to try to test them against AD passwords, you can do about 1,000 AD accounts in roughly 10 seconds, depending on the speed of your domain controller. So it's pretty easy to run all 1,000 accounts against all 744 million passwords, and that's just the dictionary attacks. Once you start with the brute force attacks, then if the passwords are too short, then it starts to you can start to be able to compromise those particular passwords. So passwords is an issue. It remains an issue, and it becomes the main gateway for people to get in and hack into organizations. Lateral attacks. I mentioned lateral attacks, but a little more detail on this, on the types of things and the way that we see the most common methods of getting lateral attacks. And one of them is really kind of scary, actually, if you think about it. Let me give you the scenario here. So the scenario is, let's say I'm John, user, and I go into my service desk, my help desk, and I've got a problem with my printer, whatever it is. The help desk personnel logs into that laptop using their admin account, and they fix the problem. They give the laptop back to that user, and they say, here you go on your way, you're good to go. Everybody's happy, everything is fine, except natively by default, that admin password has a local cached copy on that workstation. Well, those cached copies of the password are often, if you have local admin rights to that machine, those cached copies are quite easy to then attempt to run both dictionary attacks and also brute force attacks against. So we actually see this happen quite often. Is what the attacker gets in either via phishing attack, like I mentioned earlier. Once they're in on the system, they find out that that local user, John user, really doesn't have much in terms of rights, but he has local admin rights to that workstation, and they found out that an admin account actually has some local cache credentials on that machine. They hack the admin account. The password maybe wasn't long enough, or it definitely, you know, it was maybe unfortunately in the password databases, and now they have an admin account. At that point, ransomware attacks start to happen. Really bad things start to happen. You know, you get yourself into a position where you know, it's what we call a resume generating event. So and by the way, other things that hackers can do, I threw in an example there of what's called a golden ticket attack. A golden ticket attack is quite ingenious, actually. It takes advantage of the way that Kerberos creates tickets. So when you log in, you get a Kerberos ticket, and that ticket can be then reused to gain access to resource so that you're not constantly going back and forth to the domain controller. But a golden ticket is a ticket that's created that has no expiration on it. And these golden tickets then, even if an account is compromised and the organization takes the account back, the rights to the account back over again, that golden ticket is still out there. The attacker can still use that golden ticket to gain access to resources. So that's those types of lateral attacks happen quite often. So, you know, what do we do here? What's the solution to these kind of problems? And what I've done is I've taken the tools that we're going to be talking about here, the Microsoft security tools, and I've put them into what's called the National Institute of Security and Technology's cybersecurity framework. And that cybersecurity framework is divided up into the ability to identify your users, to protect your resources, to detect intrusions, to respond to those intrusions, and then to recover from them. And I've kind of thrown these various applications into there based on where their biggest strengths are. Of course, there's some overlap in between these particular areas, but we'll be talking about each one of these in detail, including some of the new name changes that some of these tools have gone through in recent months. Okay, so we'll start quickly with one of my favorite tools, and this is a tool from Microsoft called Cloud App Security. You may see it referred to by its acronym MCAS, MCAS. And what MCAS is it's what's called a multi-mode cloud access security broker, which is another acronym. In true Microsoft fashions, we've got the industry acronym, and then you've got the Microsoft acronym. But that's a long-winded way of saying that this is a tool that looks at your security exposure across multiple cloud-based applications. So you can actually take a look and see, you know, which of your users are using a particular application, what's the current security threat of that particular application. Maybe, for example, that company's been hacked within the past couple months. Maybe there's some known data leaks. Maybe they're just not, you know, not doing the proper security around their accounts. In any case, you've got tens of thousands of applications listed in the catalog for MCAS, and it ties into your infrastructure to be able to tell what it is that users are doing, not just in the Microsoft applications. Of course, you'll be able to see things like you can see on that example there, someone publicly sharing confidential files, and that's creating alerts, but also within these various other applications as well too. And so again, we'll take a look at it. We'll go through the console with an MCAS to give you a rough idea of what this looks like. Okay, so now if you've been following this space up until recently, everything that I've been talking about, or most of the things I've been talking about in the remainder of the slides, had a different name. So we now have to get used to the new names. This happens a lot. If you've ever dealt with, for example, the forefront line of tools within Microsoft, they went through so many name changes, it would spin your head. But this, of course, forefront was security related, and this is security related as well too. So For whatever reason, Microsoft changes the names quite often. So if you were used to certain names, keep in mind the new ones now. And one of the first categories that Microsoft essentially went through and renamed is what they now called Microsoft 365 Defender. Okay, and that's actually composed of several different components. The most prevalent of these components is what's called Microsoft Defender for Endpoint. And there's another one called Microsoft Defender for Identity, which I'll talk about in a later slide. But I want to focus first on Defender for Endpoint. That used to be called MDATP, or Microsoft Defender ATP. That one relies on agents that are installed on workstations and servers. Now that can be Windows, or actually there's now agents for Linux, which is why they changed it from Windows Defender to Microsoft Defender, incidentally, because it's not just Windows related. But those agents then look for different security threats on each one of these, on each one of your workstations and each one of your systems that are out there. So you will see alerts come back when users are doing things like elevating PowerShell, and there's some automatic processes that are running or trying to hide files or doing other types of malware activities that that you might expect to see. So that all gets fed into this centralized console that now, of course, has incidents not just from Defender for Endpoint, but also for Defender for Office 365 and Microsoft 365 Defender. Azure Defender, not to be confused with Microsoft 365 Defender, but Azure Defender is an area within your Azure portal, which actually has multiple components. The first one being Azure Defender for Servers. So this was previously called Azure Security Center Standard Edition, as opposed to the Security Center free edition. So there's a free tier and there was a standard tier. If you were using the standard tier, or if you're now upgrading from the free tier of Security Center, you have what's called Azure Defender for Servers. There's a component for IoT, and then there's a component for SQL Server, or SQL. So that's Azure Defender for SQL. All of these, again, had previous different components. The IoT and the SQL one I've not seen as often, not to say that they haven't been used, but Azure Defender for Servers is definitely one that was fairly common to see in the field. Okay, I talked a little bit about in the Microsoft 365 Defender space, one of the most unique tools, and what I'd say also one of the most useful, and probably my second favorite after Cloud App Security. And this is what up until recently was called Azure ATP and is now called MDI, Microsoft Defender for Identity. So how MDI works is it works by deploying sensors to your domain controllers. So you actually install these individual sensors on all the domain controllers, and those sensors look for, let's just say, weird behavior, or what looks like malicious looking behavior. So that type of behavior then is flagged and is sent up into the cloud, and it's sent up into the Microsoft Defender cloud. The Microsoft Defender cloud will then process that and say, okay, this looks like a golden ticket attack, or this looks like someone doing some suspicious LDAP queries that maybe they shouldn't have been. So it's not sending everything. It's not like it's sending all the logs up. That's actually a different tool that we'll talk about later. But it's doing a certain amount of heuristics locally on those domain controllers to see if there's weirdness going on. Now, at the same time, I should point out that you need to have these sensors on all of your domain controllers, otherwise you create blind spots. And also, I don't have it in this slide, but I'll talk about it a little bit later on. There's an on-prem version of this, which is still available, called ATA. Remember, the online version was called ATP. Well, the on-prem version is basically a series of servers that you deploy that create this whole infrastructure within your own organization. Most clients that we deal with the online version of this, so it's unlikely you'll be doing that unless you are in a highly secure situation where you can't store your security alert information in the cloud. Okay. Oh, and recently I should point out as well too. Originally, MCAS and ATP were separate, had separate consoles, and they had separate user interfaces and everything. They were effectively separate tools. Microsoft merged those two together in terms of the interface that's used to view all of the alerts and the items. And so that's now a unified dashboard experience. So you'll see everything, all your on-prem alerts that come up via MDI and your online alerts that come in via MCAS. You'll see them all within the same management console and be able to then more easily look at a history of what users are doing, both online and in the cloud. Okay, another fantastic tool I've been using at quite a few clients recently. This is Microsoft's version of a SIEM platform, a security information and event management platform. And that's what Microsoft refers to as Azure Sentinel. What Sentinel is it's a bunch of logic and graphs and charts and hunting built on top of a Azure Logs Analytics workspace. So it's utilizing some of the features of Azure Monitor and then the storage capabilities of these Logs Analytics workspace to create this SIEM that is used as a centralized location for all of your security alerts. The idea with Sentinel is that you would send your firewall logs into it, you send your syslogs into it, you send router information, router syslogs, etc. And you also ideally take logs from critical systems like your domain controllers and also file servers, which are very important, other critical servers. You install basically an operations management agent on those machines, and that agent then takes all of the events that are from that particular machine and pushes them up into this Logs Analytics workspace in the cloud. The idea being then that you can go back and forensically look at things and be able to tell who made changes on this file server at what time. So it's kind of auditing capabilities, but also, where did people change their passwords? What was going on? From a security perspective, it really allows you to drill deeply into the analytics of what's going on within your organization. One of the tabs you may see there is called Hunting. This is one of my favorite tabs because it has a bunch of built-in pre-canned queries that do things like look for deprecated authentication methods, which could be signs of someone trying to hack you, or more likely than not, it's signs of older clients that haven't been upgraded. So even from a perspective of cleaning up your organization and figuring out who's using this down-level stuff that they shouldn't be using, it's a great tool for that. It's got some great charts and graphs in it. One of the things we do at clients that use this is we'll go in weekly, create reports that show, all the malicious attacks that have taken place around the world, where they're coming from. Is there changes in that? Do we see attacks coming from different locations that we don't expect them to come from? Is there a big spike in failed logins, which would create alerts? And then we can see that in the graphs. Why are there failed logins? Is this misconfigured services, or is this someone attacking us? All of that's done through Azure Sentinel itself. Okay, a few other tools that Microsoft has out there. I talked about the problem with passwords, and one of the problems with passwords is that Microsoft really hasn't fundamentally changed much around the way the passwords operate since the late 90s. Unless you count there's some fine-grained password policy stuff that they introduced in the early 2000s. But aside from that, most people are still using the same password policies that they used in their NT4 domain, which means that they're saying, well, we need 8 characters. We need, we've got a minimum password age of 1 day. We've got a maximum of 90 days. And we're enforcing complexity, which just means that you've got to have uppercase, lowercase, and or a number, 2 out of the 3 of those things to make a secure password. The unfortunate part about that is that you can still end up creating vast numbers of passwords which can be instantly hacked because they're part of those dark web databases, or they contain the name of the person that's creating the password. One of the most common passwords right now is actually winter 2020, right? I guarantee you in a couple months, the most popular password will be spring 2021. People are just used to doing that, and they may use a capital S on the string, but that doesn't, again, that kind of a password is definitely going to be in those dark web databases. So what Azure AD Password Protection does is it extends what's called the password filter DLL that runs on the domain controllers. It extends that to be able to, for example, restrict the passwords that are being created from those that aren't in the dark web databases. It does a check against them. It restricts them from using part of their name or part of the name of the organization. And it runs then across all of the domain controllers. You do need to run it on all your domain controllers, just as with I was mentioning earlier with MDI. If you are missing it on a domain controller, you have a blind spot, which means people can change their passwords per the old policy. But when you have it in place, it allows you to then create these more complex and better password policies for your users, which then allows you, by the way, to, the good part from the end user perspective is the best practice is to not have them change their password that often. That may sound counterintuitive, but as I mentioned earlier, it's really about password uniqueness. If you have a long enough passphrase that's completely unique in the world, that can go, honestly, years without being changed, without really any security risk. There's information and there's statistics that show that changing your password too often, it actually has the opposite effect. Users just try to dumb down their password to something that they can remember because they keep changing it that often. Okay, a few other tools. There's a tool called Azure AD Entitlement Management. This is a component within Azure itself. And what it does is it allows you to create these different just-in-time type packages. So, in the past, if you needed to give someone access into Azure, oftentimes we would just, honestly give them global admin and say, here you go do what you need to do. Even sometimes vendors and other people that maybe you shouldn't be doing that to, they would oftentimes just, be given access. And hopefully you take it away when they're done with their job, or maybe you forget. That can obviously lead to issues because, the Azure Global Admin is the equivalent of the Active Directory domain administrator, which means, there's potentially issues with that. So the entitlement management allows you to create these different access packages, which then say, okay, this user has to be approved. They have to go through an approval process. And then once they are approved, they are given access to this application for a set number of days, after which point that expires. There is a subcomponent to entitlement management, incidentally, probably the most important of the subcomponents. It's called PIM, or Azure AD Privileged Identity Management. And what PIM is it's this automatic system for elevating your privileges. So, giving an example, this case, you'll see the user Jack is eligible for the global admin role. And what that means is that in any general period of time, even if you log in as Jack, you actually are not a global admin. You have to then first go to PIM and elevate yourself. And the elevation will go through an approval process. So that way, if someone hacks Jack's account in the middle of the night, it's unlikely they're going to be able to do anything because they wouldn't be able to elevate in Azure because, either people wouldn't be there to approve it, or they would get suspicious as to why Jack is trying to elevate in the middle of the night. So that's just, again, one example is that it's the idea of like just in time. You're giving that just-in-time admin access when it's required and not before the point. In a perfect Azure environment, you actually have only one user or maybe two users that are global admin permanently, and those are what we call break glass accounts. So those are just in case PIM goes down and you need to get a backdoor in to be able to do something in Azure as part of an emergency. Otherwise, everybody has to elevate into their roles if you have PIM set up properly. The on-prem version of PIM, there's actually an on-prem version that Microsoft has called MIM, and there's a component that sits on top of MIM, Microsoft Identity Manager, and that component is called PAM, or Privileged Access Management, which is, interestingly enough, of course, that's very confusing with PAM is confusing with PIM. So the one thing I do want to point out here, aside from the fact that Microsoft has a tool to do this, we do have clients that use this. It does automate the admin accounts from being added in. For example, they get added in as domain admins only temporarily, and then they get removed out of the group. The point that I want to point out in this diagram is the bastion forest, because that's actually a concept that's really, I see this taking off in the next couple years or so. The idea of a bastion forest is it's a separate forest that your corporate forest trusts, but that it doesn't trust the corporate forest. And that bastion environment contains all of your admin accounts, or the majority of them, except the break glass ones. And then when a user needs to log in as an admin, if they're using PAM, for example, they log in as the bastion one, they request to be added in domain admins in the corporate forest, and then they're temporarily given access to that. Even if you're not using MIM and PAM, however, you can still use a bastion forest, because it allows you to do things such as lock down the forest, use server core domain controllers, use the most secure security templates, the mil-spec security templates. All of that stuff can be done because it's a separate forest, and you're not tied into all of the legacy problems that you have when you're doing upgrades within your corporate environment. So in a best practice world, your admin accounts all exist within Bastion, and then they're added as members across that trust. They're added as members to the appropriate groups within the corporate environment. Again, that makes that nearly much more difficult to hack an environment when you're using a Bastion forest. Okay, other tools within the Microsoft space, there's what's called Azure Information Protection. This is a security tool that really, the concept is protecting your content after it's been accessed. And it does that through various approaches, one of which is using what's called Azure Rights Management Services, or Azure RMS. And what Azure RMS does is it's a certain type of encryption that you apply to your documents that can only be decrypted if the client agrees to certain restrictions. One of those restrictions would be you can't copy paste content. Another one would be you can't do save as. The idea is it's supposed to slow down data leakage. Of course, someone could pull out their mobile phone and take a picture of the screen. That does happen, but I guarantee you it's a lot harder to steal large sums of information one picture at a time. Besides, that could be searched. People could figure out that you're doing things. Things like Azure RMS really help you to protect the content, more long term, or protect the massive data leakage. Because remember, again, it's not, a lot of times these things are accidental. It's not that you have someone maliciously sharing things. They may just accidentally put it out there. Well, if you're using Azure Information Protection, it can protect against that oversharing, or even if it is overshared, it can put restrictions in place so that the user that gains access to this cannot do certain things with that data. Okay, I've put together this chart here just to kind of give you a rough idea of the way that Microsoft licenses and deploys these various tools. So you'll see up there, of course, the coolest tools, MCAS, MDI, PIM, PAM. Those do require either an Azure AD Premium P2 license or a Microsoft 365 E5. But you can also use some of the other tools. If you just have a P1, you could technically use the on-prem version of MDI called ATA. Otherwise, you still can use a lot of these things, with the exception, of course, you'll note there's pay-as-you-go for things like Security Center if you're using the standard edition, or Azure Sentinel. Azure Sentinel is based on a log ingestion and a log retention basis, with the majority of the cost being the ingestion of the data, and the long-term retention being, of course, much cheaper. It's much cheaper to store things on disk than it is to just get it in there in the first place. But compared to what I've seen for other SIEM applications, it generally comes out relatively cheap. Of course, these are US dollar prices, and do check with Microsoft. These are just the rough published prices, but this gives you an idea of roughly how Microsoft markets these things. Your location, your region may be different. Of course, your pricing may be different, and your currency very likely will be different, particularly considering this audience that I'm dealing with. But that, again, gives you a rough idea of what we're dealing with here. Okay, I'm going to briefly show some of these things here and then leave a few minutes for questions. I particularly wanted to poke around within Cloud App Security, because Cloud App Security, from a perspective of getting insight into what's going on within your organization is fantastic. You note that I have an alert here that's telling me I'm coming in from an infrequent country. Well, okay, this is a test tendency. I never log in, so the flag thinks that a login from the US is something that I should know about. Now, of course, if I get a lot more logins from the US, this won't be flagged. But if I suddenly get a login from, you know, Sudan or something, it will flag that. You'll see this this particular alert show up. There's other types of things, you know, hey, guess what? This particular user did 27 suspicious activities. You know, maybe this is a bad thing. This is technically Microsoft seeding the platform. So when I spun up this particular test tendency, it ran through and did a bunch of automated options that the application saw as suspicious. So again, that's the kind of thing you can see from that. So again, here are a list of all of our different alerts. But I also wanted to show you from a cloud discovery perspective what we can see from a discovered app perspective. These are our fake users. I can actually go into and take a look at them and see, you know, what applications they're using, how much traffic they're using. And then, you know, the great part about this is that if they were using an application that was compromised, I'll get alerts on that. And I'll see, hey, you have these 10 users that used applications, these particular applications. You should probably reach out to them and determine, you know, if there's something going on here. You know, again, you'll see the activity, of course, was only during the provisioning process. If we had a real environment here, you'll see a lot richer information. But this gives you an idea. Let me go through some of the apps that are discovered out here as well too. You'll notice Microsoft gives scores to these types of applications. So the scores are based on. Let's actually look at the full app catalog here. Let's see, because we only have so many apps in our test tendency. But the scores that they'll give vary widely depending on the application. Some of these, of course, have terrible scores because they're just, you know, they don't really follow any of the security protocols that they're supposed to. So again, from just a perspective of gaining insight into what's going on within your organization, gaining insight into the workstations that are out there, who's logged into the workstations, the history of a particular IP address, all of this is done through MCAS itself. And then, of course, I can view always allow the same information within Microsoft Defender for Endpoint, which, as I mentioned earlier, this is the MDATP application. This gives us, you may recognize this as MDATP, but this is the tool that I mentioned that allows us, that has the agents running on each one of the workstations, and I can do things like isolate an individual device. I can say, you know, I want this to be isolated where it can't do anything, or I can isolate it except for Outlook and some applications on it. I can restrict individual devices. I can look at incidents and try to use this to determine, you know, what's going on. Do I have a compromised system here? In this case, this actually was a very suspicious thing that Microsoft was running just to seed again this environment here. So once this loads up, you'll see that they were trying to run a PowerShell commandlet that would give them rights to that particular system. So this is, yeah, this is a particularly bad one that they were essentially attempting to take over a system and run a golden ticket attack from that particular system. Real briefly, again, a few other things. Azure Information Protection, I talked about this. Definitely take a look at it. Azure Security Center. If you haven't taken a look at Security Center, at a minimum, go in. Every Azure environment has it. Take a look at your secure score, which will show up, of course, if you have a real active subscription in here. But your secure score will allow you to go in and take a look at some of these things. If you are licensed for this as well, too, you'll see the Azure Defender piece show up here, and then you'll see the charts and graphs that are fed into it from the various Azure Defender applications themselves. Okay, I am going to go back into here. Please fill out the eval. The eval codes are up here, and I'm going to then segue into the few minutes I have left for questions. If you don't get your question answered, also please feel free to reach out to me, or if you're watching this video later on, reach out to me on the various locations that I've mentioned up there. I do have a travel blog, incidentally. It's called sharingtheglobe.com. I have not updated in years, unfortunately, but there's still some great stories on it. I just haven't gotten around to putting in some of the later stories. But I've traveled at this point to 175 countries. There are, 19 or 17 left to go to. I was hoping to get to them at the end of, it was supposed to be in 2021, but obviously that's been set back. So hopefully I'll get there eventually, but hope to see you somewhere around the world at some point, and I'll leave it open to questions. Okay, I don't see, let's see, I don't see any questions yet in the chat window. We'll give it just a couple more minutes here. I do, by the way, make my slides available on SlideShare. You should see, maybe not the latest copy of this. I'll copy a later copy if there's maybe an older version of this slide deck. Thank you, Christopher. I appreciate the compliments. Let's see if there's anything else. That, by the way, that picture is in Bhutan. That's the Tiger's Nest Monastery. It's a bit of a hike to get up there, but it's well worth it when you may have seen it. Actually, it's fairly well known. Bhutan is one of those countries. Their big thing is they have this concept called gross national happiness. So instead of gross national product, they focus on the happiness quotient. So thank you, Sebastian. Thanks, Claudia. All right. Okay, well, I don't see many questions, so I'm going to segue off because I think we have another session coming up. But thanks again for the time. I really appreciate it. Hope to be back again someday in Germany, France, Europe in general. It's been a while. I made it to Portugal in January, and then everything shut down after that. So hope to get back again sometime soon. I've been to every country in Europe. I would love to go to every single one at several more times. So hope to get back again sometime soon, and thank you very much.